Hi, welcome to the Potential of All Potentialities. This is the Remembering the Future segment on what is the visible universe made of. Hopefully it will get you excited about coming out to see one of my live events at one of the various conferences and expos where I appear. You can always find out by going to x2radio.com and clicking on the Events tab on the left-hand side. Easy to do. So let's talk a little bit about the universe. What is it made of? Well, it's made up of protons and electrons. It arranges itself in particles we call atoms. Atoms are made up of these protons and neutrons. Neutrons are formed by combining a proton and an electron, like a +1 and a -1 equals 0. That's a neutron. So these protons and neutrons collect each other together in nuclei, which form atoms by atomic number. The electrons are on the outside around it. I'll explain a little bit more about that in a minute, but I want to talk about the proton itself, because the proton is kind of a mystery. We have splattered these little beggars apart with CERN billions of times, and we pretty much know the menu of particles it takes to make up a proton. But for all that knowledge, for all the collection of all these menus, the frequencies, the energies that it takes to make a proton, we still cannot form a single proton. We don't know how to make one. We can take them apart, but we can't put them together. One of the things that we have learned about them is that they're put together with various energies in resonance with one another. They're different frequencies, different wavelengths, and they kind of form a holographic resonance. That is to say, when they resonate with each other, they come together as a proton. If they don't resonate, then they just end up as chaotic energy in the universe. When they come together, it's a little bit like the principle of when we make images. We make images using color dots. We arrange them in CMYK, which is cyan, magenta, yellow, and black, or RGB, which is red, green, and blue. And when we combine all these colors together, we get white. When we separate them apart, we get the different wavelengths, and we can arrange them in what's called a stochastic pattern to create an image. When we separate them apart, they make color. When we combine them, they make different colors. And the point is that we can make an image like this flower that we see. Now, this flower, if you look at it, you can see all the components. You can see the petals, you can see the iris, you can see the pistil, you can see all the detail of this flower. But if we were to zoom in really deep on this picture, what you would really see are dots. You would see these cyan, magenta, yellow, and black dots arranged, set close to one another in a certain pattern. This is, of course, with blowing this all the way up to thousandths of an inch so that you can see what's making it up. It's the same thing as a proton. Same thing as a proton. But the interesting thing about that picture of that flower that I showed you, it's a little pale. It's because a sampling of these dots has been removed. Not all one color, but some of all the colors, so that you get a kind of more pale image of it. If we were to put all that energy back in, all those frequencies back in, you'd get a much more rich, full color of the flower, like this. You see, all the yellow is there, all the red is there, all the green is there. Now you can really see the detail of the flower. This is holographic theory when it comes to resonating frequencies together to make matter. The other particle we talked about is electricity. Now let me explain a little bit more about electricity. I wish we knew more about the actual electricity itself. We know how to use it, we know the math associated with it, we know when we flip the light switch on, it comes on. We know how to generate it, we know that we can rub a magnet along a wire and induce a current flow in that wire, but we don't really know where the electricity comes from. We don't know where the electrons come from. When we think about electrons, we think about these tiny little particles, 1 electron volt, and we know basically what they are, but we don't know where they are or what their speed is. So what we think about in terms of electrons is a Heisenberg uncertainty. That is to say, Every single atom has a certain number of electrons around it that matches the number of protons, but we don't really know where they are exactly, and we don't know how fast they're going, but we have a probability. We call this an electron cloud. So this is how we understand atomic chemistry. So when we think about the four forces of the universe, and I'll explain those in just a moment, we think about the strong and weak molecular forces, which are the ones that hold those neutrons and protons together. We think of electromagnetism, which is the principle of magnetics and electricity forming a force that we can use, but we don't really understand where it comes from. And that makes up the four forces of the universe. But of late, many physicists, including one of my old colleagues, Sir Roger Penrose, we are thinking about a fifth force of the universe. We're thinking about a force called consciousness. What the argument is, or what the disagreement is what is the order of importance. Now, Sir Roger Penrose said consciousness is the result of quantum gravity, that principle, one of the four forces. I later stated that actually quantum gravity is the result of consciousness. And John A. Smolin wrote, we're not working with a brain that's near absolute zero. It's reasonably unlikely that the brain evolved quantum behavior. In other words, there's some overarching, omnipotent creator consciousness in the universe. It creates downward causation. That is to say, consciousness didn't evolve from anything. In fact, when we think about consciousness, it is this quantum foam force in the universe. We know that if we apply consciousness with direct observation and intention, we can affect the thing that we're observing just by looking at it. So when you think about these four forces, again, we're talking about gravity, electromagnetism, and the strong and weak molecular forces. We added to that consciousness. The argument, and I maintain probably more intelligently, the arrangement of these should be like this: consciousness, electromagnetism, strong and weak molecular forces, and then gravity. 5 forces in the universe, not 4. So when we think about these protons, they're not all the same. Remember, we talked about them being holographically different. Some of the dots are removed, all of the dots are there. The hydrogen proton is the heaviest proton in the universe. It has all of the color, all of the frequencies are there. Helium, which you see on this proton chart, is significantly lighter than hydrogen. That is to say, the one hydrogen proton is like this, and the 2 helium protons put together are like this. Now, yes, helium is more mass because it is 2 protons together, but each proton had to lose a little bit of weight to get there. And if you take that and look at it in a form of an equation, it looks like E is equal to mc squared. That is to say, energy is equal to the mass of that proton times the speed of light squared. That's c squared. That's a lot of energy. That is how nuclear fusion, to fuse these 2 protons together. We're not fusing 2 hydrogen protons together. We're fusing 2 lighter protons together. Each one of those hydrogen protons had to lose enough weight to become a helium atom. And that times the speed of light squared is a tremendous amount of energy. This is the force of consciousness in the universe. Truly, it is the driving force of the universe. This is the principle in remembering the future. Thank you for joining me on this potential of all potentialities segment of Sci-Spy TV.